Hi, this is Introductory Econometrics, Lecture 4. The topic is regression analysis. My name is Yusuf Ashir. Let's go. The nature of regression analysis. Regression analysis is concerned with the study of the dependence of one variable, called the dependent variable, on one or more other variables, called independent variables. The goal of regression analysis is to estimate or predict the average value of the dependent variable based on the known values of the independent variables. Let's look at regression analysis examples. Example 1. An economist may be interested in studying the dependence of personal consumption expenditure on disposable income. Such an analysis may be helpful in estimating the marginal propensity to consume, that is MPC, that is average change in consumption expenditure for, say, $1 worth of change in disposable income. Example 2. A monopolist may want to find out the response of the demand for a product to changes in price. Such an experiment may enable the estimation of the price elasticity of demand for the product and may help determine the most profitable price. Example 3. A labor economist may want to study the rate of change of money wages in relation to the unemployment rate. Such knowledge may be helpful in stating something about the inflationary process in an economy. For increases in money wages are likely to be reflected in increased prices. Example 4. The marketing director of a company may want to know how the demand for the company's product is related to, say, advertising expenditure. Such a study will be of considerable help in finding out the elasticity of demand with respect to advertising expenditure, that is, the percentage change in demand in response to, say, a 1% change in advertising budget. The knowledge gained from this analysis may help to determine the optimal advertising budget. Now, let's look at statistical versus deterministic relationships. In regression analysis, we are concerned with what is known as the statistical, not deterministic dependence among variables. In statistical relationships among variables, we essentially deal with random or stochastic variables, while in functional or deterministic dependency, on the other hand, we also deal with variables, but these variables are not random or stochastic. So what do you mean by a random variable or a stochastic variable? A random variable is a variable that can take on any set of values with a given probability. Now, regression versus causation. Although regression analysis deals with the dependence of one variable on other variables, it does not necessarily imply causation. The point to note is that a statistical relationship in itself cannot logically imply causation. To ascribe causality, one must appeal to a priori or theoretical considerations. Thus, one can invoke economic theory in saying that consumption expenditure depends on real income or disposable income. Regression versus correlation. In correlation analysis, the primary objective is to measure the strength or degree of linear association between two variables, or more than two variables, depending on the type of regression we are looking at. If it's a simple regression, it depends on the type of correlation analysis we are looking at. If you are looking at simple correlation analysis, we are dealing with linear association between two variables. So if you are dealing with correlation among more than two variables, we are dealing with multiple correlation analysis. Or at times, we may be dealing with partial correlation analysis. So the correlation coefficient measures the strength of linear association between two or more variables. For example, we may be interested in finding the correlation coefficients between smoking and lung cancer, between scores on statistics and mathematics examinations, between high school grades and college grades, and so on. In regression analysis, as already noted, we are not primarily interested in such a measure. Instead, we try to estimate or predict the average value of one variable on the basis of the fixed or known values of other variables. Thus, we may want to know whether we can predict the average score in a statistic examination by knowing a student's score in a mathematics examination. Thank you. This is the end of this lecture. So see you in lecture 5.